All right, today we're going to do something really cool. We're going to map the invisible. We're diving into a force that can guide a compass, power a car, and yet you can't see it, you can't touch it, you can't taste it. We're talking about magnetism, and by the end of this, you'll get exactly how we can actually see its incredible power.
I mean, just think about that for a second. If you've ever played with two magnets, you know that feeling. That bizarre, springy push when you try to force them together, or that powerful, sudden snap when they pull each other close. It's a mystery right in the palm of your hand. How is that action at a distance even possible?
Well, to answer that, we have to understand that magnetism isn't just any old force. It belongs to this really special group of forces, the ones that don't need to actually make contact to get things done.
So in physics, forces pretty much get sorted into two big buckets. You've got your contact forces, pretty straightforward, right? They require a direct touch, like pushing a box or the friction that stops it. But then you have the really fascinating ones, the non-contact forces. These are kind of like the ghosts of the physical world. Think about gravity holding you to the Earth right now. Or, of course, magnetism. They act across totally empty space.
The secret to this invisible power is something called a magnetic field. You see, every single magnet creates this field of influence in the space all around it. You can almost picture it like an aura. And any other magnetic object that wanders into this zone is going to feel its push or pull. It's the literal map of the magnet's power.
And that's the core idea right there. The force itself is invisible, sure, but that doesn't mean it's unknowable. And the key word in that quote? Visualized. Because scientists and engineers have found some really clever ways to reveal the hidden shape of this force.
Which, of course, brings us to the next big question. If you can't see a magnetic field, if you can't smell it or touch it, how in the world do you draw a map of it? How do you turn that invisible feeling of a push and a pull into a picture you can actually see?
Well, it turns out you don't need a supercomputer or a billion-dollar laboratory. Nope. All you really need are a few simple things you could find in any high school science class. So let's make the unseen visible. This is the classic experiment, and honestly, it's brilliant because it's so simple. You just take a magnet, put a piece of paper over it, and you start sprinkling these tiny little bits of iron on top. At first, it's just a mess, but then, with a gentle tap on the paper, that's when the magic happens.
It's incredible. Those little iron filings, because they're magnetic themselves, they instantly snap to attention. They physically arrange themselves along the invisible lines of the magnetic field. They form this beautiful, elegant pattern of sweeping curves. And you have to understand, this isn't some artist's drawing. This is a direct physical map of the magnetic field.
And this map tells us two absolutely crucial things. First, it shows us direction. The lines always flow out from the North Pole and loop around into the South Pole. Second, it shows strength. See how the lines are all bunched up and packed really tightly at the poles? That's where the force is the strongest.
And hey, the iron filings aren't the only way to prove this. You could take a tiny little compass and move it all around the magnet. At every single point, that compass needle would point perfectly along those same lines. You could trace it out, point by point, and you draw the exact same pattern. It proves this field is a real, consistent thing.
Okay, so a bunch of iron filings makes a cool pattern. Big deal, right? So what? Why does any of this actually matter? Well, because that simple pattern isn't just a party trick. It's the fundamental idea behind some of the most powerful and important technology that we use every single day.
Just think about it for a second. MRI machines that let doctors see inside our bodies without ever making a cut. Electric motors that power everything from your kitchen blender to a Tesla. Even the simple magnetic lock on an office door. All of them work because we understand how to control these invisible fields.
And that right there is the crucial leap. Once we could see the pattern with something as simple as iron filings, we could begin to understand it. And once we understood it, we could learn how to harness it, how to control it. That journey from just observing something to actually applying it, that's the heart of all science and engineering.
So, an MRI machine, it's just using incredibly powerful and precisely shaped magnetic fields to get particles in your body to line up and create an image. An electric motor? It's just using rapidly switching magnetic fields to create motion. Both are just unbelievably advanced versions of that same simple push and pull force we saw with a magnet and some iron filings.
And really, that's the key takeaway here. So much of our modern world, whether we're talking about magnetism or gravity or even radio waves, is built on our ability to find simple, clever ways to see the invisible forces that run the universe. Because once we can see the pattern, we can unlock its potential.
It really makes you wonder, doesn't it? What other unseen forces are out there?
shaping our reality right now, just waiting for the right kind of iron filings to come along and finally reveal their secrets.